And now in this lecture we will find the radius of the circle. In the drawing we have a circle, and inside the circle we have quadrilateral ABCD. Actually, quadrilateral ABCD is inscribed inside this blue circle, and we also know that side AB, this side of quadrilateral ABCD, equals to 3 units, so we will define side AB as A. That is to say, AB equals to A, and we know that AB equals to 3 units, therefore A will be also equal to 3 units. We also know that side BC of quadrilateral ABCD equals to 4 units. So we will define side BC as B, that is to say BC equals to B, and we know that B will be equal to 4 units because BC equals to 4 units also. We also know that side CD of quadrilateral ABCD equals to 5 units. Therefore, we will define side CD as C. So C will be equal to 5 units because CD equals to 5 units and CD equals to C. So CD equals to 5 units. And it is given us the question, the side AD equals to 6 units. Therefore, we will define side AD as D. And D will be equal to 6 units because AD equals to D and AD equals to 6 units, therefore D will be also equal to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. So first of all, I will present to you 3 new rules, and we will implement the rules in our drawing. So rule number 1 states that the area of quadrilateral ABCD equals to actually that is the sign of area. This means that the area of quadrilateral ABCD, it will be equal to the root of S minus A times S minus B times S minus C times S minus D. Actually, A, B, C, and D in this equation are the lengths of the sides of this quadrilateral ABCD, and S equals to A plus B plus C plus D over 2. That is to say, it equals to the sum of quadrilateral ABC sides over 2. Okay, so if you have quadrilateral ABCD, and actually quadrilateral ABCD is inscribed by this circle, I will repeat again. Quadrilateral ABCD in the red color is inscribed by this circle, and we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. So, according to rule number 1, the area of this quadrilateral ABCD again, this is the sign of the area of quadrilateral ABCD. It will be equal to the root of S minus A times S minus B times S minus C times S minus D A, B, C, and D are the lengths of this quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Okay, so if a quadrilateral is inscribed by a circle, then you can calculate the area of that quadrilateral according to this formula. A, B, C, and D are the lengths of the quadrilateral sides, and S equals to the sum of the quadrilateral sides over 2. Okay, actually, that is rule number 1, and we also have rule number 2. According to rule number 2, quadrilateral ABCD is inscribed by a circle, again, quadrilateral ABCD could be any quadrilateral. So we know that quadrilateral ABCD is inscribed by a circle then the product of its diagonals equals to the sum of the products of its opposite sides. So I'll repeat on rule number 2 again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and quadrilateral ABCD is inscribed by this circle, we know that side AB of quadrilateral ABCD equals to A units in each side. We also know that side BC of quadrilateral ABC equals to B units in each side, and we also know that side CD of quadrilateral ABCD equals to C units in each side, and also side AD of quadrilateral ABCD equals to D units in each side. Then, according to rule number 2, the product of its diagonal quadrilateral ABCD has two diagonals. The first diagonal BD, this is the first diagonal, diagonal BD, we will define diagonal BD as x, that is to say the size of diagonal BD equals to x units, so BD equals to x unit in size. And we also have second diagonal AC. We will define the second diagonal AC as y, that is to say the size of diagonal AC is y units. Then, according to rule number 2, the product of its diagonals, the product of quadrilateral ABCD diagonals is actually x times y. And the product x times y equals to, according to rule number 2, equals to the sum of the products of its opposite sides. Diagonal quadrilateral ABCD has two pairs of opposite sides. The first pair is side AD is the opposite side of side BC. So the product of the first opposite sides will be B times D, and the second pair of opposite sides is actually side AB is opposite to side CD, and the product of the second opposite sides, it is actually A times C, and the sum of the products of its opposite sides is actually BD plus AC. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. Okay? So I'm repeating again. If quadrilateral ABCD is inscribed by a circle like this, quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals quadrilateral ABCD has two diagonals, diagonal AC and diagonal BD. So the product of its diagonals is x times y equals to the sum of the products of its opposite sides, equals to the sum of the products of its opposite sides, equals to BD plus AC. Okay? So if you have quadrilateral ABCD, that would be any quadrilateral, and this quadrilateral ABCD is inscribed by a circle like in this drawing, then the product of the diagonals is x times y, and according to rule number 2, x times y equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is actually BD plus AC. Okay, so xy equals to BD plus AC. Okay, so that is rule number 2, and we also have rule number 3. According to rule number 3, So rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So I repeat on rule number 3 again. Rule number 3 says that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 5? The meaning of rule number 5 is that if you have this circle and triangle ABC is inscribed by this circle. Okay, triangle ABC is inscribed by this circle. This is triangle ABC, and we also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. Then according to rule number 3, so we have triangle ABC that it is inscribed by this blue circle. Then according to rule number 3, the radius of that circle, the radius of this blue circle, that is to say capital R, equals to the product of triangle ABC sides. The product of this triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC. Over 4 times the area of triangle ABC. So according to rule number 3, if we have triangle ABC that could be any triangle that it is inscribed by this blue circle, then the radius of this circle, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangles ABC sides. That is to say, it will be equal to A times B times C over 4 times the area of this triangle ABC. Okay, so now the radius of this blue circle that blocks triangle ABC will be equal to ABC, that is the product of triangle ABC sides over 4 times the area of triangle ABC. Okay, so we will implement all 3 rules in our drawing. This is our original drawing, and so according to rule number 1, the area of this quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D. So here A, B, C and D are the lengths of quadrilateral ABC sides. AB equals to A, BC equals to B, and CD equals to C, and AD equals to D. And we know that D equals to 6. Okay? Also we know that all the 4 sides, the length of all the 4 sides of triangle of quadrilateral ABCD. So the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, and S equals to the sum of quadrilateral ABC sides, that is to say it will be equal to A plus B plus C plus D over 2. So that is the implementation of rule number 1 in our drawing. We will also implement rule number 2 in our drawing. According to rule number 2, we have quadrilateral ABCD as 2 diagonals. Diagonal BD, we define diagonal BD as X, that is to say the size of diagonal BD equals to X units, and we will define diagonal AC as Y, that is to say diagonal AC equals to Y units in its size. So according to rule number 2, if we have quadrilateral ABCD, that could be any quadrilateral that is inscribed by this blue circle like in our drawing, then the product of its diagonals, that is to say X times Y, will be equal to the sum of the products of its opposite sides. So the first product of its opposite sides is B times D, and the second product of its opposite sides is actually A times C, and according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is BD plus AC, because the first product is BD and the second product is AC, and the sum of the products of its opposite sides is BD plus AC. And this sum of the products of its opposite sides equals to the products of its diagonals, that is actually x times y. That is according to rule number 2. Again, equation number 2 is the implementation of rule number 2 in our drawing, and we also have rule number 3. So we have, if you relate to triangle ABC, triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides. The product of triangle ABC sides, it is actually A times B times Y, over 4 times the area of triangle ABC. This is true according to rule number 3. This equality is true according to rule number 3. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABY over 4. Here we will divide equation number 3 by R, and we will get the area of triangle ABC. Okay? We will get that the area of triangle ABC equals to ABY over 4R. Okay, after we divided equation number 3 by R, we got that the area of triangle ABC equals to ABY over 4R. Okay, so in the next step we will focus on triangle ADC. This triangle ADC. So as you can see from the drawing, triangle ADC, this triangle is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to to the product of triangle ADC sides, that is to say it will be equal to C times D times Y over 4 times the area of this triangle, triangle ADC. I repeat again, because of the fact that triangle ADC is inscribed by this blue circle, therefore the radius of this blue circle that blocks triangle ADC, according to rule number 3, will be equal to the product of triangle ADC sides, that is to say, will be equal to C times D times Y over 4 times the area of triangle ADC. Here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDY over 4. So here we will divide equation number 4 by R, and we will get the area of triangle ADC. So according to equation number 4, the area of triangle ADC will be equal to CDY over 4R. So we found the area of triangle ADC equals to CDY over 4R, and we also know the area of triangle ABC. Okay? But as you can see from the drawing, quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Therefore, the area of quadrilateral ABCD will be equal to the sum of the areas of those two triangles, triangle ABC and triangle ADC, that quadrilateral ABCD consists of. Okay, so I write it down. The area of this quadrilateral ABCD in the red color equals to the area of triangle ABC plus the area of triangle ADC. As you can see from the drawing, quadrilateral ABCD consists of exactly those two triangles. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Okay? So I will repeat again. The area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. The area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC that quadrilateral ABCD consists of. Here we get that the area of quadrilateral ABCD equals to the area of triangle ABC, but we have already found out that the area of triangle ABC equals to ABY over 4R plus the area of triangle ADC. But we have already found out that the area of triangle ADC equals to CDY over 4R. Okay, so we will take y over 4r as a common factor of those two expressions, and we will get that the area of quadrilateral ABCD, according to equation number 1, equals to, so we took y over 4r as a common factor of those two expressions. So what's left inside the brackets? Inside the brackets, left from these expressions only AB, and here what is left after we took y over 4r as a common factor, what is left is only CD. So we found out that the area of quadrilateral ABCD equals to y over 4r times AB plus CD. Okay? So in the next step we will focus on this triangle BDC. So we will focus on triangle BDC. As you can see from the drawing, this triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to triangle B, the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4R of the area of triangle BDC over 4 times the area of this triangle BDC. This is according to rule number 3. So here we will multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCX over 4. Here we will divide equation number 5 by R, and we will get the area of triangle BDC. So according to equation number 5, the area of triangle BDC will be equal to BCX over 4R. So we found out that the area of triangle BDC equals to BCX over 4R. So in the next step we will focus on triangle ABD. So as you can see from the drawing, this triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangles ABD sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD, according to rule number 3. I repeat again, triangle ABD is inscribed by this blue circle, and therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides. That is to say, it will be equal to A times D times X over 4 times the area of triangle ABD. This is true according to rule number 3. So here we will multiply equation number 6 by ABD, that's the area of triangle ABD, and we will get that the area of triangle ABD, or R times the area of triangle ABD, equals to ADX over 4. So here we will divide equation number 6 by R, and we will get the area of triangle ABD. So we get that the area of triangle ABD, according to equation number 6, equals to ADX over 4R. Okay, if you found out the area of triangle ABD, and we have already found out also the area of triangle BDC. But actually, as you can see from the drawing, quadrilateral ABCD consists of those two triangles. Okay, if you add triangle BDC to triangle ABD, you will get quadrilateral ABCD. Again, if you add triangle BDC to triangle ABD, you will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD that quadrilateral ABCD consists of. So I'll write it down. The area of quadrilateral ABCD according to equation number 2 will be equal to the area of triangle BDC plus the area of triangle ABD. I will repeat again, the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD, because of the fact that quadrilateral ABCD consists of those two triangles, and if you add triangle BDC to triangle ABD, you will get quadrilateral ABCD. So the area of quadrilateral ABCD will be equal to the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCX over 4R plus the area of triangle ABD. But we have already found out that the area of triangle ABD equals to dx over 4r. So the area of quadrilateral ABCD will be equal to, here we take x over 4r as a common factor of those two expressions, and inside the brackets we will have here from this equation what is left is BC, and from this expression what is left after we took out x over 4r as a common factor, what is left is AD. So according to equation number 2, the area of quadrilateral ABCD equals to x over 4r times BC plus AD. But we have already found out, according to equation number 1, that the area of quadrilateral ABCD equals to y over 4r times AB plus CD. So we actually have two different expressions for the area of quadrilateral ABCD. So we will multiply equation number 1 by equation number 2, and we will get the area of quadrilateral ABCD squared. It's equals to x times y over 4r squared times BC plus AD times AB plus CD. So here we will take a root out of this equation number 3, and we will get that the area of quadrilateral ABCD according to equation number 3 will be equal to the root of this expression in the numerator. That is to say, it will be equal to the root of x times y times BC plus AD times AB plus CD and the root of 4r squared is 4r. Okay, why? Because the root cancels the square, and what is left is 4r. So we found out that the area of quadrilateral ABCD according to equation number 3 equals to this expression. Here we will multiply equation number 3 by r, and then we will divide it by the area of quadrilateral ABCD in order to get the radius of the circle that we are looking for. So first of all, we will multiply equation number 3 by r, and we will get that r times the area of quadrilateral ABCD equals to the root of x times y times bc plus ad times ab plus cd over 4. Here we divide equation number 3 by the area of quadrilateral ABCD, and we get the radius of the circle that we are looking for. We get that the radius of the circle that blocks quadrilateral ABCD equals to the root of x times y, in the brackets we have BC plus AD, times AB plus CD, over 4 times the area of quadrilateral ABCD. Okay? But what is x times y that we have in equation number 3? X times y, according to rule number 2, equals to AC plus BD. Okay, x times y equals to AC plus BD according to rule number 2. So we will substitute xy in equation number 3 by AC plus BD, that equals to xy according to rule number 2, and we will get that the radius of the circle that we are looking for equals to the root of, again, instead of xy, we will write down AC plus BD, that equals to xy times BC plus AD times AB plus CD, all divided by 4 times of quadrilateral, 4 times the area of quadrilateral ABCD. So because of the fact that we know the values of ABCD, A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units, the only thing that is left to find in order to get the radius of the circle is the area of quadrilateral ABCD. Actually, we have already found out the area of quadrilateral ABCD according to equation number 1, according to rule number 1. I will repeat again on the same formula. According to rule number 1, the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. But we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So according to this data, we will find out that S equals to A is 3, B is 4, C is 5, and D is 6 over 2. So S equals to 3 plus 4 is 7, and 7 plus 5 is 12, and 12 plus 6 is 18. 18 over 2 is 9. So we found out that S equals to 9. So we can substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD equals to the root of S is 9, A is 3, so it is 9 minus 3 times S minus B. S is 9, B is 4, so it is 9 minus 4. S minus C. S is 9 and C is 5, so it is 9 minus 5 times S minus D. S is 9 and D is 6, so it is 9 minus 6. So the area of quadrilateral ABCD will be equal to the root of 9 minus 3 is 6, 9 minus 5, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So the area of quadrilateral ABCD will be equal to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Okay, so after we found out the area of quadrilateral ABCD, we will substitute the area of quadrilateral ABCD in this equation number 3 by the root of 360 square units, as we already found, and we will get that according to equation number 3, that the radius that we are looking for equals to AC plus BD times BC plus AD times AB plus CD and the area of quadrilateral ABCD equals to the root of 360 square units, and it is actually divided by 4. Okay, so we have the values of A, B, C, and D. So the only thing that is left to do is to put the data inside equation number 3 in order to get the radius of the circle that we are looking for. I will write down the values of A, B, C, and D. It is giving us the question that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So according to equation number 3, the radius of the circle that we are looking for will be equal to the root of AC. A equals to 3, C equals to 5, so 3 times 5 is 15, plus BD. B equals to 4, D equals to 6. 4 times 6 is 24, times BC. B equals to 4, C equals to 5, so 4 times 5 is 20, plus AD. A equals to 3, D equals to 6, 3 times 6 is 18, times AB. A equals to 3, B equals to 4, so 3 times 4 is 12, plus CD. C equals to 5, D equals to 6, so 5 times 6 is 30, all divided by 360 over 4. Okay, so the radius of the circle that we are looking for will be equal, according to this equation number 3, to the root of 15 plus 24 is 39, 12 plus 18 is 38, and 12 plus 30 is 42, all divided by 360 over 4. So actually here 39 times 38 times 42 over 360 is actually 172.9, all divided by 4. So we actually found out that the radius of the circle that we are looking for equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle that we are looking for equals to 3.287 units. Okay, so I will repeat again. The radius of this circle that blocks quadrilateral ABCD will be equal to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle will be equal to 3.287 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle for the ABCD is inscribed by this circle, the blue circle, and we also know that AB equals to 3 units, so we defined AB as A, and A will be equal to 3 units. And we also know that BC equals to 4 units, therefore we defined BC as B, and B will be equal to 4 units. And CD equals to 5 units, therefore we defined CD as C, and C will be equal to 5 units. And we also know that AD equals to 6 units, so we defined AD as D, and D will be equal to 6 units, and we want to find out the radius of this circle that blocks quadrilateral ABCD. Okay, so in order to find out the radius of this circle, I presented to you 3 new rules, and we implemented those 3 new rules in our circle and quadrilateral. Rule number 1 states that the area of quadrilateral ABCD, the area of quadrilateral ABCD equals to, this is the sign of the area of quadrilateral ABCD, it will be equal to the root of s minus a times s minus b times s minus c times s minus d. Actually, a, b, c, and d are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. Okay, so whenever you have a quadrilateral that it is inscribed by a circle, then you can find out the area of that quadrilateral according to this formula, when A, B, C, and D are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. Okay, that is rule number 1, and I also presented to you rule number 2. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So if we have this quadrilateral ABCD is inscribed by this blue circle, therefore the product of its diagonals, quadrilateral ABCD has 2 diagonals. Diagonal AC is defined as y, or it equals to y units in its size, and quadrilateral BD is defined as x, that is to say quadrilateral diagonal BD equals to x units in its size. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. So quadrilateral ABCD has 2 pairs of opposite sides. AD is the opposite side of BC, and the product of the first opposite sides is B times D, and quadrilateral ABCD has the second pair of opposite sides, that is actually AB is the opposite side of CD, and the product of the second pair of opposite sides are A times C, and the sum of the products of the 2 opposite sides, it is actually BD plus AC. So that sum of the opposites, that's the sum of the 2 opposite sides, or the product of the 2 opposite sides, or the sum of the product of the 2 opposite sides is BD plus AC, and this sum equals to the product of its diagonals, that is to say x times y. Again, if a quadrilateral ABCD is inscribed by a circle, like in this drawing, quadrilateral ABCD is inscribed by this blue circle, therefore the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is BD plus AC. So according to rule number 2, x times y, that is the product of its diagonals, equals to the sum of the products of its opposite sides, that is actually BD plus AC, or xy equals to BD plus AC. Okay? And we also have rule number 3, according to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and triangle ABC is inscribed by this circle, as you can see from the drawing, therefore the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times C over 4 times the area of triangle ABC. Okay, so if you have a triangle that is inscribed by a circle, like in this drawing, then the radius of that circle that blocks the triangle will be equal to the product of its sides. In this case is A times B times C over 4 times the area of triangle ABC. Or over 4 times the area of that triangle that is inscribed by a circle. Okay? So then we implemented the 3 rules in our drawing. According to the first rule, the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of this quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Okay, so if you have a quadrilateral, it is inscribed by a circle, then you can find out the area of that quadrilateral according to this formula. So that is rule number 2, and we implemented also rule number. This is rule number 1, and we implemented also rule number 2 in our drawing. According to rule number 2, if you have quadrilateral ABC, that could be any quadrilateral that it is inscribed by a circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say it will be equal to BD plus AC. Okay, and then we implemented also rule number 3. According to rule number 3, if we have this triangle ABC is inscribed by this blue circle, therefore according to rule number 3, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of triangle ABC. Okay, so we multiply the equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABY over 4. So here we divided the equation number 3 by R, and we got the area of triangle ABC. So the area of triangle ABC equals to ABY over 4R. Then we focused on triangle ADC. Triangle ADC is inscribed by this blue circle, therefore according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times Y over 4 times the area of triangle ADC. According to rule number 3, we multiply the equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDY over 4. Then we divided the equation number 4 by R, and we got that the area of triangle ADC equals to CDY over 4R. So we got the areas of triangle ABC and triangle ADC. But as you can see from the drawing, quadrilateral ABCD consists of two triangles, triangle ABC and triangle ADC. So if you add triangle ABC to triangle ADC, you will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC that quadrilateral ABCD consists of. So, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. So here, the area of quadrilateral ABCD equals to the area of triangle ABC, but we have already found out that the area of triangle ABC equals to ABY over 4R plus the area of triangle ADC. We have already found out that the area of triangle ADC equals to CDY over 4R. Here we took a common factor of y over 4R out of this equation number 1. We got that the area of quadrilateral ABCD equals to y over 4R, and inside the brackets we will have here what is left is AB, and in this expression what is left is only CD. So we got that the area of quadrilateral ABCD according to equation number 1 equals to y over 4R times AB plus CD. Okay, then we focused on this triangle BDC. This triangle BDC is described by the blue circle. Therefore, according to number 3, the radius of the blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of triangle BDC. We multiply the equation number 5 by the area of triangle BDC, and we got that R times the area of triangle BDC equals to BC x over 4R. Then we divided the equation number 5 by R, and we got that the area of triangle BDC equals to BCX over 4R. Then we focused on triangle ABD. We know that this triangle ABD is described by this blue circle. Therefore, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times X, A times D times X over 4 times the area of triangle ABD. According to rule number 3, we multiply the equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADX over 4. Then we divided the equation number 6 by the area by R, and we got that the area of quadrilateral ABD equals to ADX over 4R. So we got the areas of triangle BDC and triangle ABD. But we know that the area quadrilateral ABCD consists of those two triangles, triangle BDC and triangle ABD. So if we add triangle BDC to triangle ABD, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ADB. Okay, so the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. So the area of quadrilateral ABCD will be equal to the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCX over 4R, and the area of triangle ABD equals to ABX over 4R. Here we took a common factor of x over 4r out of these two expressions, and inside the brackets we have BC plus AD. So we found out that the area of quadrilateral ABCD equals to x over 4r times BC plus AD. But we already found out that according to equation number 1 that the area of quadrilateral ABCD equals to y over 4r AB plus CD. So we multiplied equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. And then we took a root out of this equation number 3, and we got that the area of quadrilateral ABCD equals to the root of this expression, and the root of 4r squared equals to 4r. Here we multiplied the equation number 3 by r, and we got that r times the area of quadrilateral ABCD equals to this expression, and we divided equation number 3 by the area of quadrilateral ABCD, and we got that the radius that we are looking for equals to this expression. So here inside equation number 3 we have xy, but we know that according to rule number 2, xy equals to AC plus BD, so we can substitute xy in equation number 3 by AC plus BD, that equals to xy. So we substituted that xy by AC plus BD, and we got this expression. And then we found out the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to, according to rule number 1, equals to this expression, and S equals to A plus B plus C plus D over 2. We know that A equals to 3, B equals to 4, C equals to 5, and D equals to 6. Therefore, S that equals to A plus B plus C plus D is 3 plus 4 plus 5 plus 6 over 2. It equals to 9. Then we substituted S in this equality by 9, because S equals to 9, and we got that the area of quadrilateral ABCD equals to 9 minus 3 times 9 minus 4 times 9 minus 5 times 9 minus 6. That is actually 6 times 5 times 4 times 3. That is actually 360. So we found out that the area of quadrilateral ABCD equals to the root of 360. Then we substituted the area of quadrilateral ABCD that equals to the root of 360 in this equation number 3. And we got this expression, and we have all the values of A, B, C, and D. So we put the data inside this equality, and we got here AC is 15, PD is 24, BC is 20, AD is 19, AB is 12, and CD is 30. And 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42. Okay? And the root of 39 times 38 times 42 over 360 is 172.9 over, so all divided by 4. So we found out that the radius of the circle that we are looking for equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. So we have here two answers to the same answer, that the area of quadrilateral, the area of this circle, the radius of this circle will be equal to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay? Thank you very much.